The next speaker is Karen Kafadar, sorry, I got it wrong. Karen Kafadar from the University of Virginia, and she's going to talk about statistical issues and reliability of eyewitness identification.
Thank you, and thanks to all of you. My goodness, this is a bigger audience than I would have expected for the last day of the conference and after lunch. And so thank you, the organizers, for inviting me, and thank you to all of you for staying. And I guess, as you say in this country, now for something completely different. But I did want to say that the last talk, Colin's talk, reminded me of many years ago, the Denver Press called me and asked me if I would comment about a study that was published in Nature, if you can believe it. And it was the use of Where's George dollar bills to understand the spread of influenza. So apart from the fact that, first of all, I didn't even know what a Where's George dollar bill was. So if I'd gotten one of these, I wouldn't have known. I was supposed to go to a website and log in where it was and when I spent it and everything else. Apart from the fact that it violated just about every one of Alicia's rules about sampling of banknotes, I don't know what it had to do with the spread of influenza. So I'm happy to say nothing ever went to about, nobody ever commented further about the article. So that was my only experience with banknotes. This, as I say, this talk today is a little bit different from what we've been hearing about, but I think that it brings together some issues about using eyewitness identification as a tool, some of the statistical issues in terms of designing for the law enforcement officers, and also involves some psychology. So I think all those are being represented by the program. So let's see here if I've figured this out. There we go. So I'll give you a little bit of background in the report and then talk about one specific aspect of it, and the statistical aspects primarily, and some final thoughts. So eyewitness identification is never quite this easy, although sometimes it's amazing how they will kind of stack the lineup so that one person stands out. But it's not supposed to be like that. They're supposed to make them, sort of hard to, a little more like they resemble each other. So the task is pretty straightforward. It's a binary decision problem and a binary outcome. So your typical confusion matrix here, where each person really serving as an eyewitness in eyewitness identification, each eyewitness is kind of a binary classifier. A really important case was this one involving Ronald Cotton and Jennifer Thompson. There's actually an entire 60 Minutes show devoted to this, and they actually wrote a book called Pickin' Cotton. Jennifer Thompson in 1984 was a college student. She was raped. Police sketch, they pulled in Ronald Cotton as one of the 6 photos. Jennifer reluctantly narrows down the 6 photos to 2, and then reluctantly decides, well, maybe it was, I think this is the guy. The detective says, "You sure?" And she goes, "Positive." "Did I do okay?" And the detective said, "You did great." Then they did a live lineup, and only Ronald Cotton was repeated from the photo lineup. So not surprisingly, that's the one that looked familiar, and that's the one she picked. But when she got into the courtroom, she said, "I'm 100% sure that's the guy who raped me." He was convicted to life in prison plus 54 years, and then in '95 he was exonerated by DNA, and they arrested Bobby Poole, who, by the way, in the meantime, had raped several other women. Here's another case, and in this case, here's a photograph of the lineup that they showed the victim, and the victim had described her attacker as well-built with a round face. Okay? Well-built with a round face. Okay, class. How many of you think it's number 1?
I think I know.
Number 2? 3? 4? 5?
That's fine.
Okay, you are all correct. Okay? However, the victim said number 3. Number 3. Now, this guy doesn't seem to have a round face. Matter of fact, I wouldn't even call him well-built. I mean, if anything, the kid looks scrawny. And he's kind of sitting there kind of looking cocky because he knows he didn't do it. Okay. Nonetheless, this fellow, White, was convicted. In the courtroom, the prosecutor says, do you see the person in the courtroom here today that came into your apartment that night? And she points and says, that's him. Well, you can imagine in the courtroom this is quite powerful. And he was convicted to 22 years in prison and was later exonerated. So how do these misidentifications occur? Well, people believe that your memory is like a photograph. You feel like you can remember perfectly what happened many years ago, but in reality it's fallible. It's influenced by many factors. And the psychologists in the memory literature classify it into 3 stages. One is, how good was the data when you acquired it in the first place. It's going to depend on various environmental conditions and whether there was good lighting or not. What they call the data handling stage, how good is your memory? Okay, and then there's the retrieval stage, and how well are you able to spit it back, recall it. And of course, with more time, there's more degradation. By the way, there's an article in the New Yorker only a couple weeks ago, and apparently Scotland Yard has realized that there are some people who are really good at comparing faces. So they'll see the picture on CCTV, and then they'll find that some of these people are really good going out on the streets and recognizing them. So there is differential abilities in eyewitnesses. So eyewitness testimony can really be very useful and incredibly powerful in the courtroom, but as we know, memory can play tricks. It can be inaccurate and unreliable. In the Innocence Project, a database of 330 exonerations since 1980 involving post-conviction DNA testing, almost 3/4 of them involve mistaken eyewitness testimony. That's not the only evidence, but 3/4 of them involved it. So what's involved in eyewitness identification and what aspects lead to accurate and inaccurate assessments? So the committee charge was to critically assess the existing body of literature, identify gaps in the literature, provide an assessment of what can be learned from research fields outside of eyewitness identification, because as so often happens, the field becomes very closed without realizing there's a whole body of literature in other fields that could bear on the problem. And then offer recommendations for the best practices, and there were 3 others. So it won't come as any surprise, I think, to anybody who thinks a little bit about it, that it's affected by many variables. And you could classify those variables as those that are beyond your control. They're just, environmental aspects of the problem. And sometimes in the statistics ledger, we call these noise variables. They're out of your control. So things like how much stress the eyewitness was under at the time, what were the conditions, how far was the witness and the perpetrator, whether there was a threat, whether someone had a gun to your head, whether there was a distinctive feature on the person, other distractions, if you're in a crowded bank or a metro station, versus just one-on-one. They have something called the cross-racial or cross-ethnicity effect. They have found that some people, it's harder for them to recognize people from different races or different ethnicities than their own. The time, of course, the retention interval, age of the witness, that's just some of them. But then there's some what we call procedural aspects, and these are sometimes in the statistics ledger we'll call these control variables, things that are under control. The big portion of the literature in eyewitness identification, believe it or not, has to do with lineups. Of all these variables, degree of similarities, how similar do you make the fillers to the potential suspect, the number, the nature of the instructions when they're doing an eyewitness identification, presence or absence of feedback, whether you make it a blind, the person who actually hands the photos has nothing to do with the case, for example. With all these things, believe it or not, the literature, huge, disproportionately of interest, amount of the literature concerns the particular lineup. So I'm going to talk about that, although keep in mind that all these comparison procedures apply to any of the variables. Again, as statisticians, we know that there are multiple kinds of experiments that you can run to look at more than one variable at a time. It was kind of surprising how few actual factorial experiments were run. where they manipulated more than just one variable. So I'm going to focus on this one question that they spent an enormous amount of time in the literature on, which is sequential versus simultaneous. So in sequential, as you can imagine, they present one photograph at a time, and in simultaneous, they present all the photographs at once. And in early research, they said sequential is more accurate. And later research said, no, the metric you're using for comparison is incomplete. Actually, simultaneous is more accurate. And so the question is, which is correct? So what were the lab tests that they used? Well, typically, as you can imagine, a lot of these things, they use Psych 1 students. I actually took Psych 1 when I was in college and was required to do 3 of these experiments. My only objective was get through this experiment and get out of there as fast as possible, right? So probably the kinds of environments in which they're basing a lot of these recommendations are not exactly the stressful kind of situations that a real eyewitness would go through. Not that, by the way, that's easy to replicate. I'm just pointing out that there's going to be a disconnect between the types of experiments they use to evaluate these things and what probably might happen in real life. In any event, they would count the proportions of correct IDs and mistaken IDs and then look at that ratio. So the early research collapsed all the participants, all the scenarios in a test, and they would compute this hit rate over the false alarm rate, which we would think of as sensitivity over 1-my specificity, or what we sometimes would call the ordinary likelihood ratio. And they conclude that sequential is better than simultaneous. Well, as I say, the later folks came along and said, no, you have to recognize that some participants have more confidence in their assessment. And confidence is related to accuracy, they claimed, and so therefore we should be looking at this diagnosticity ratio as a function of expressed confidence. Okay? And if you do that, then actually it's the reverse, so which was correct. So, what does a statistician do? Well, always thinks about all the sources of uncertainty. Certainly sensitivity and specificity are important. Of course, in real life, what we really want to know is whether the eyewitness was right or wrong. Positive predictive value and negative predictive value are, of course, functions of sensitivity and specificity. So I want to point out that this LR positive, or diagnosticity ratio that they were using, is related to positive predicted value, where here's the odds ratio, in that a higher LR positive leads to a higher positive predictive value. So for the same odds ratio, a higher LR positive would lead to a higher positive predictive value. So there's the equation again. But then in the medical literature, they also recognize that there's something that they call LR negative. And that's going to be the probability, the 1-my sensitivity or specificity. That one actually relates to negative predictive value, in that a smaller LR minus is related to higher negative predictive value. Now, law enforcement cared about negative predictive value too, because if the eyewitness says, no, it's not Bobby Poole, okay, and Bobby Poole goes on and commits more crimes. So they really care about both. They're very concerned, and they couldn't really say if one was more important than the other. They really do care about both. So and by the way, I can never resist a plot. Positive predictive value is actually affected more by specificity than sensitivity. So there's my little plot. On the x-axis is the P, prevalence. On the y-axis is the positive predictive value. Both are on log scales. The black curves are specificity is 0.7, then 0.8, 0.9, 0.95, and 0.99. The individual curves relate to sensitivity. So you can see specificity has more of an effect on PPV than sensitivity does. Now it's the reverse for negative predictive value. Okay, so their sensitivity are the black curves at 0.7, and sensitivity 0.99 is at the top, and the individual curves relate to different levels of specificity. So what about this confidence-accuracy relationship? Well, it's not really clear that accuracy was related to confidence. So during the committee, John Wickstead presented a manuscript. I believe it's been published now. And he had these data. The things in parentheses are the things that I added here. 44 people responded with a confidence rating 1, 2, and 3, and the accuracy was 0.61. and you can see the data there, and said, you see, accuracy is related to confidence. So I plotted it, and with 3 points, not a big surprise, that slope was not significant. What's plotted there are plus or minus 2 standard errors. The weighted mean is 0.77. The other studies have suggested that perhaps there is a relationship. In the field, law enforcement officers had a kind of a mixed impression. Some of them said they think that it is related, and some people said, I don't think it has anything to do with it at all. So the reality is that accuracy is likely to be a function of many variables, system, estimator, study design variables, and so forth. But if you believed that confidence were related to accuracy, then you could consider computing this diagnosticity ratio as a function of the different ECLs, split the sample participants into how confident they said they were, or even better, plot hit rate versus false alarm rate for different levels of ECLs, expressed confidence levels, which encourage you to think about a receiver-operator characteristic, ROC curve. Certainly not a new concept by any means, but new to this field. I think Schuhart developed it about 100 years ago for quality control literature. It's been used in compare medical diagnostic procedures and so forth. So what does a statistician do? Well, thinks about uncertainty. Many years ago, John Tukey came to National Cancer Institute, and somebody asked him, how would you compute the uncertainty in cancer mortality rates and cancer incidence rates? And this was the first thing that he said. He did get around to answering the question. But I thought this was so interesting that I wrote down. He said, what has happened is history. What might have happened is science and technology. So what you're really interested in is what might have happened if you could do it all over again. So what I did is I took some data that was in the papers, and I simulated what would have happened if you'd repeat the experiment all over again. And really here, all I did was binomial variation. I am quite sure this is way underestimating the amount of variability in the study. And then I plotted them to see what they'd look like. So the Q's here are the data points, the original data points in the article for the sequential, and the M is for simultaneous. And I plotted it there with plus or minus limits of 1 standard error, and then plotted this diagnosticity ratio, or LR positive, versus the expressed confidence level. Doesn't look like there's a big difference, although I do want to call attention to the fact that the slope here is probably about 15. And then here it is, and here it looks like the slope is more dramatic, but the y-axis is actually quite a bit narrower. So in any event, it looks like there is substantial variability, at least in these studies. And these studies usually involve several hundreds of people. But here are the ROC curves from two of the experiments. Again, the data points are what was in the article. The Q's for sequential and the M for simultaneous. I plotted it with plus or minus 1 standard deviation, 1 standard error. And it does look, at least for the last 3 points, that there looks like there certainly could be a difference, although a lot of overlap in the beginning. But this one is really more typical of the ROC curves that I computed. A lot of overlap. So in my mind, it certainly wasn't clear yet, highly established sequential was better than simultaneous. As I say, the uncertainty that I computed here is almost surely underestimated for many reasons. First of all, if you ask me now and you ask me later, I might have a different answer. The responses are probably not independent from these studies, because I'm guessing, just based on my own experience when I was a Psych 1 student, they didn't just have me do one trial. I mean, they had me do a whole bunch of trials now that they've captured me. The likely more variability in the proportions and simple binomial variation. So it's highly variable. I think it's pretty clear that this expressed confidence level in a lab experiment is going to be a lot different than in a real-life, highly stressful situation. 50% may mean something different to the same person one day to the next, as well as the different procedures. Much more than expressed confidence levels likely to affect diagnosticity ratio. In real life, a law enforcement officer is not going to go to one of these blokes coming off the street and say, can you tell me how confident you are? 10%, 20%, 30%? The only thing that the law enforcement officer can do is say, can you explain in your own words sort of, how sure you feel about this? And then translate the answer into sort of a level of confidence. And the way I translate it may be different from the way somebody else translates it. We still don't know if it's related to accuracy, lack of independence in the data, And Wells complained about ROCs because they say compare only 2 levels, but I don't see that as a big statistical issue. But is there another measure of confidence? I don't know. So the committee report said, well, I think you ought to think about other analyses. Here's an example of, for example, look at the log, the logit of the hit rate and the logit of the false alarm rate, some combination of those. And just taking some data, this is one of the few studies, Carlson and Carlson, in 2014, they actually did do a factorial experiment. They had 3 conditions: simultaneous, where the target was in place number 4, sequential, where it was in number 2, and sequential, where it was in number 5. 2 weapon conditions, whether it was present or absent. 2 distinctive features, whether it was present or absent. Then they computed this ECL-based ROC curve and compared the partial area into the curve, which has some criticisms due to the fact that partial arises on actually how the data showed up. What was the result? In any event, I'm not saying by any means that this was the most thorough or complete analysis. It's only the analysis I could do because those were the data in the paper, but nothing looked significant. I think we certainly do need other tools and other plots. Wells, Yang, and small r's had suggested computing the what they called an info gain plot, which was the difference between the prior p and the posterior probability. So I actually did that for some of the data, and I wasn't quite sure how you would interpret this. That was another plot that they suggested. Both plots involve curves. Curves are hard to interpret. 1 over the posterior probability is 1 plus OR, odds ratio divided by this diagnosticity ratio. So if you were to plot 1 over the posterior probability versus the odds ratio, the slope would be 1 over the diagnosticity ratio, and you'd see differences in the slopes as indications of differences in expressed confidence levels. And so there you go. To me, I just find it easier to interpret straight lines than to interpret curves. One alternative that I thought about was, whether you could, because LR positive and LR negative are related to PPV and MPV, maybe we ought to do something like a bivariate linear model for LR positive 1 over LR negative, or the logarithms of those, so that both are high, since you would want the outcome to be high. Let's see here. I'm going to skip to the last 2 things. This was a plot. I'm going to skip to the committee findings and then 2 studies that have been published since. One is they said take the eyewitness statement as soon as possible after the eyewitness identification. Consider doing a blind lineup where I assemble the photos and then I hand them off to somebody and somebody else actually administers it. They said, this is really too difficult. This is too difficult. And we kept reminding them that they said that in clinical trials too, and they figured out how to do it. Record the remarks following the statement. Administrators should provide no feedback, none of this, yeah, you did great. Conduct studies on effects of jury instructors. There was no recommendation in the report about which lineup type was better, and consider other metrics for comparing the procedures. I want to tell you about 2 other studies that came out since then. This one was, New Jersey actually did implement a lengthier set of instructions for jurors when they are seeing evidence from an eyewitness. And so they wanted to see what was the effect of those new instructions, the New Jersey version or the standard version. And they recruited people from Amazon Turk, 335 so-called jurors, told them to watch a 35-minute trial video. And the trial video either had what was called weak ID quality or strong. So weak being, poor lighting, far away, didn't have a distinctive feature, didn't have a weapon, so forth. Different conditions, and then, strong. And so they found that the percentage that convicted was different between the standard and the New Jersey, regardless of whether it was strong or weak. It was always they were less likely to convict with New Jersey. And so they took this as meaning that the New Jersey instructions were, could have the potential for not convicting enough. I actually was trying to figure out, I kept reading the article to try to figure out, was the guy guilty?
Yeah.
I know. I kept trying to figure out. So they never said in the article, if the guy that was on trial was actually the guy in the video. So I don't know. I mean, maybe they were right not to convict. I don't know. So it's an interesting study that bears repeating under other conditions. And then this one, and I'm not making this up, this was the title on the NIST webpage. Study reveals forensic facial examiners can be near perfect. So the task that they were given was to view two pictures, the same or different person. They had 27 honest-to-goodness facial ID examiners, 14 that were controls. They were actually forensic examiners, just not trained in facial examination, and 32 University of New South Wales undergraduates. They were all attending a facial identification scientific working group meeting. The three tests that they used here were these different tests to examine their performance. But I want to point out that the test was looking at two pictures. They were either both upright or both inverted. They could look at them for either 2 seconds or 30 seconds, but they had as much time to decide as they wanted to. Not surprisingly, the examiners did better than the controls, who did better than the students. And if they pooled took like majority vote from like 8, 9, 10 examiners, then they did pretty well. Okay, so if they asked a whole bunch of examiners to look at them, so when they say it was near perfect, they don't report that in that one sentence line that actually it was based on pooling information. So I think that there's still a lot of work to be done here. Accuracy is likely to be related to many variables, and I don't even think you need real complicated models to do it. But I do think it'd be interesting to try to combine these two things, LR positive 1 over LR negative. Eyewitness can be thought of as a binary classifier. I think, as we all know, there's a lot of research on binary classifiers. A lot of relevant literature characterizing the reliability and accuracy of those. And I'll just end with 3 of my favorite quotes from John Tukey. There's a T-shirt that ASA sells, says, "Statistics means never having to say you're certain." But Tukey used to say, often a problem can benefit from more than one approach, try several. He was a big believer in that. What we do tomorrow may differ from what we do today, and finding the right question is often more important than finding the answer. So there are some references, and I think I came close to being on time, did I? Yeah.
Thank you very much. Any quick questions? But we're actually going to put everybody out here and line up in just a moment.
The title of that paper was "They Can Be Perfect," right? So
Yes.
it's hard to falsify that.
Yes.
The "can be" might be 1 in a million times or something like that.
Yeah, it can be near. Well, I guess you're right, language, yeah. Yes.
I have a question. You probably already said this and I missed it, but when they're comparing simultaneous versus sequential and then using expressions of confidence, presumably that might well be affected by whether or not it's sequential versus...
You got it. Exactly. And that was one of the concerns that was actually expressed in the report that said, the way you express your confidence could depend on what it is you're comparing in the first place.
Yeah.
Right.
So that wasn't...
One question there.
Wouldn't psychologists say that in a simultaneous lineup, you've actually excluded a bunch of people, and that's in your brain, whereas in a sequential, you're only eliminating sort of one at a time, and you may have more confidence because all at once you've eliminated a bunch, as opposed to sort of one at a time, even 5 in succession, because with a sequential, there's always a question
About whether you can go back.
You kind of go, yeah, that's the one. And I can easily see that psychological issue would bear upon the issue of confidence.
Yeah, and the law enforcement officers did say that potential eyewitnesses would, even in a simultaneous, they would literally set them aside and say, I'm pretty sure this wasn't it. With the sequential, it kind of depended on the field office, because I think many of them said you can go back. Okay, you can go back if you would want to. Yeah, but that was another procedural variable that could be affected. Yes. I think there are 2 more, Jeffrey and you.
I wanted to ask if there is any studies linking it to the level of stress at the time of examination. So, for instance, if the person really has certain pressure to identify the person, or if it's just a casual exercise.
Yeah. Keith, I'm going to have you repeat the question because it was a little hard for me to hear.
If I get this right, I guess my voice wins. that the level of stress at the time would have an effect, including the stress put upon the individual by the officer to actually make the ID.
Exactly, exactly. And that was one of the reasons that they were trying out some of these different eyewitness identification instructions, hopefully to put the eyewitness at ease, because they did recognize that the whole situation is stressful.
If it's other way around, so for instance, if especially the instructions to increase the level of the witness, would it improve the rate or it would decrease the rate? So for instance, if there is some even material insensitive to recognize the person as fast as possible or something else like this.
Don't know if we tested that. Yeah, I'm not sure if we tested that. Yeah, thank you, Jeff.
Okay, well, I think we should move on now to the next bit, but we can also continue. You can continue also
Okay.
putting questions to.
Now, I think I should take this off, right?
Yeah, you should take this off. Jane is going to take over as chair. Personal